Now let us see major types of satellite imagery. We will discuss this spot, Landsat TM, that is Thematic Mapper, and Landsat MSS multispectral, and IKONOS. These are the major satellite imagery products used in various institutions and industries. So let us start with Spot. Spot is launched by France. This is the name, I can't pronounce it. And this is by their space agency. It was launched, actually there were 5 spots, Spot 1, Spot 2, Spot 3, Spot 4 and Spot 5. Spot 1 was launched in 1986, it was decommissioned and reactivated in 1997. While the Spot 2, it was launched in 1990 and still going on. Spot 3 was launched in 1993 and it stopped functioning in the year 1996. And Spot 4, it was launched in 1998, still going on. So we have Spot 2. Spot 1, Spot 2 and Spot 4 which are still going on, and Spot 5 which was scheduled on April 2002, so we have it. Now Spot satellite are in Sun synchronous orbit. This is the Sun synchronous orbit. The satellite passes on the same part of the Earth at roughly the same local time region. This is what means if you have local conditions and 10:30 you want that satellite to be there, so every day it will pass there. Though it revolves around the sun number of times, but for that particular time they see. And its inclination is around 8 degrees off polar orbit. The fact that the Earth is not perfect sphere makes the orbital plane, this is the orbital plane, rotates slowly around the Earth, right? Now the slow motion of that orbital plane matches the latitude motion of the sun in the sky over the year, and it maintains similar sun angles along its ground trace for all the orbits. This is how it takes place, and this means that the area the sun flies over always get the same sunlight angle, which gives constant light. This is sun synchronous. Now this is for Landsat, but the idea is the same for Spot. Like this is your orbital plane. The orbit plane rotates at the mean rate of the Earth about the sun. So you'll find it at the same time. That is why you are asking about sun, so it will be synchronous with the sun. So each Spot satellite carries 2 HRV, that is high resolution visible HRV. These are the HRV instruments. HRV sensors constructed with multilinear array detector, or we call it as push broom scanners, also known as along track. Whisk broom and push broom. So push broom is along track. So these we call multispectral image data along a wide swath. See, this is the swath. So you have HRV1, you have HRV2, and the swath means the area it is going to cover literally is up to this number. So push broom uses linear array of detectors, so it senses single column at a time and uses forward motion, like the way you broom your house or clean your house, it is just like that. So it senses single column at a time and uses forward motion to generate second image. While this GSD, ground sample distance, or we call it as a resolution, special resolution is there, is set by sampling interval, normally results in just touching square pixels making up the image, and each spectral band of sensing requires its own array. Right? So push broom scanners generally have higher radiometric resolution because they have longer dwell time. This radiometry resolution means if an image is 8-bit, so 2 to the power 8, we say that 8 is the radiometric resolution, and it can give you 256 shades. Dwell time then across which across track scanners does not have, which moves laterally across landscape as also moves forward. So this is Spot. The position of each HRV unit can be changed by ground control to observe a region of interest that is at oblique angle and the satellite up to 27 degree plus minus relative to the vertical. So if this is vertical, so this angle can be plus 25, this angle can be minus 25, minus 27. This is how the coverage time actually increases. So of Nadir, this is the Nadir. Of Nadir means these 3. So of Nadir we allows for acquisition of stereoscope imaging, because you have this image from one position and the other image from other position. This is the concept of stereography. So acquisition of stereographic imagery, because we get a parallax here, and provides a shorter revisit interval of 1 to 3 days. The spot oblique viewing capacity allows it to image an area within a 900 km swath. 900 km swath. So this can be used to increase the viewing frequency for a given point during a given cycle also, and the frequency also varies with latitude at the equator. A given area can be imaged 7 times during the same 26-day orbital cycle, and at latitude 45 degree, a given area can be imaged 11 times during the orbital cycle, and 157 times yearly, and an average of 2.4 days. This is very good, with an interval ranging from around maximum of 4 days to a minimum of 1 day. So any point on 95% of that will be imaged any day by one of the 3 satellites. There are 2 modes in which spot grabs the image: panchromatic and multispectral. What is this panchromatic and multispectral mode we can achieve from spot? Panchromatic is single spectral band corresponding to the visible part of the electromagnetic spectrum without the blue, from 0.51 to 0.73 micrometer, which is the range of visible. We have just left this blue one. And single channel imaging mode so yields black and white images. Resolution is 10 meter, which is pretty good, and pixel per line is 6000 and good for 5 millimeter detail. While if you talk about a multispectral, also known as colored, so 3 spectral bands: XS1 from 0.5 to 0.59, that is green; XS2 0.61 to 0.68, that is red; and XS3 0.79 to 0.89. This is gone up to near infrared (NIR). Okay, from 0.7, this near infrared starts. So resolution is 20 meter. So the pixels gets half, it's 3000. These are the example of spot images. This is a mosaic false color tiles of Australia. This is again a spot image. And let us talk about Landsat now. This was first started by NASA in 1972. Landsat is the biggest hit, but later turned over to this NOAA. Since 1984, satellite operation and data handling are managed by a commercial company called EOSat. Landsat 1 launched in 1972, lasted till 1978. Then comes Landsat 2, launched in 1975. 3 more satellites are launched in 1978, 1982 and 1984. That is Landsat 3, 4, 5. Then Landsat 6 in 1993, but it failed. Landsat 7 launched in 1999, and for information, only 5 and 7 are working. So for like spot, we have just discussed spot. Landsat is also synchronous, and it is about 8 degree off the polar orbit. 8 degree off. So its repeat cycle is about 16 days and always crosses equator at around 10 a.m. 10 a.m. equator. So orbit takes about 99 minutes. That is roughly 99 minutes means 90 minutes in 1.5 hour. 1.5 hour roughly. So 14.5 per day orbit are possible. Distance between ground tracks of consecutive orbit is around 2,752 km at equator because of the Earth's rotation. And by following Earth's rotation with each pass, it can keep crossing the equator at the same time. Swath is around this 183 degree wide, although that includes this overlapping, since data frame is 170 km. Right? This is 170 km, so there has to be some overlapping also. And as I suggested, 233 orbits for each 16-day cycle. This is the swaths, how it goes on. And this is the difference between 2 swaths, 2752 for 1 day and another day. Scenes are then indexed by the path and row. This is the path, and this is the row. See? So scenes are then actually the scenes which we utilize. This is how it is seen by row number and path. So Landsat 4 and 5 have 2 types of sensors, MSS and TM, Thematic Mapper and multispectral sensor. So MSS started at Landsat 1, and terminated in late 1992. 80 meter resolution with 4 spectral bands from visible to this near infrared IR. Only Landsat 3's MSS sensor had a 5th band in thermal IR. Landsat, this thematic mapper started with Landsat 4. So wavelength range from this thematic sensor is from your visible, that is blue also included, through mid-IR, mid-IR, into 16 detectors for the visible and mid-IR wavelengths, 16 detectors. Bands in the thermal thematic mapper sensor, it provides 60 scan lines on each active scan. 4 detectors for the thermal IR band provide 4 scan lines in each active scan. Because this TM sensor has a spatial resolution of 30 meter for visible NIR and mid-IR wavelengths and spatial resolution of 120 meter for the thermal IR. So Landsat 4 and 5, this MSS, the TM, with MSS we have 4 bands, TM we have 1, 2, 3, 4, 5, 6, 7, and this is actually your mid-infrared, and these are the bands, these are the wavelengths. Resolution is 80 for MS multispectral. For thematic mapper we have resolution of 30, only thermal IR has over 120. Landsat MSS now. MSS multispectral has a square instantaneous field of view IFOV with around 11.56 degree field of view, and this is the scanning arrangement of MSS. You can see the sphere 185 km. These are the scan lines per band, and this is the field of view as we call it. This is the field of view, which is around this much degree, and this is how it goes in a upper view. So Landsat MSS, this broom run, that push broom scanner, that is also known as across a track scanner. So satellite motion provides an axis of the image and other axis provided by the oscillating image. And it uses 4 sensors array, 6 sensors each. And one array for each band, 6 sensors are included because this allows the ground coverage rate to be achieved at 1/6 the single line scan rate. Analog signal is converted into digital onboard and then it is sent. So has somewhat poor radiometric resolution, only 6 bit, that means only 2 to the power 6, that is 64 values. Landsat TM thematic mapper, more bands, better spatial and radiometric resolution, 256 digital numbers instead of 64. And both resolution improvements plus the fact that the green and red bands are narrower make it better for vegetation discrimination than MSS. Also, near infrared in TM is narrower and centered in a region that is highly sensitive to the plant rhythm. The TM is also a whisk broom scanner, but it collects data during both west to east and east to west sweeps of the scanner, unlike MSS, which only does for the forward, like only east to west, west to west. It allows individual detectors that can dwell on an area and scan through a field of 15.4. We have just seen this. 7 scans per line. That's slow rate that limits estimation of mirror, which improves geometric integrity and boosts the signal to noise ratio. Thematic mapper uses 16 detectors per parameters, except the thermal 4, which use 4. This is Landsat TM applications, various applications. You can pause and see. For various purposes it is used. If we talk about this thermal, right, it has soil moisture, thermal mapping, vegetation stress, and various people or scientists, researchers has found some or the other use in every band. So this is Landsat TM. This is an example. August 40. This from 1999, and this is October 17, 1999, which is of Salt Lake City area. And differences in the color is due to change in the season. Landsat 7. Landsat 7 uses a new sensor called the Enhanced Thematic Mapper (ETM+), and it stresses continuity with Landsat 4 and 5. In that, uses similar orbit and repeat patterns as well as similar to 185 km swath width for imaging. And you can go here and you can find out more information. This is how ETM Plus is organized. This is the figure of actual Landsat 7 machine. So Landsat 7 special resolution of bands are like this. Band 1, 5 and 7. Resolution is 30 meter. This bits per sample is 8 for everyone. 6 and 8, the resolution is again 60, but 8 it has resolution of 50, the better one. Landsat 7, these are the spatial resolution of the bands. You have 8 bands, SC157 to 8. So blue, green, red, NIR, MIR, and thermal IR, and mid IR, and panchromatic. So blue, green, red up till 0.7, 0.69. Then you have 0.7 to 0.9, 1.5 to 1.7, 10.4 to 12.5, 2.09 to 2.35, and again 0.5 to 0.9, that is the panchromatic. So your eighth one is the panchromatic. So you have good resolution, 15 meter. Okay, band wavelength spectrums are slightly different from our Landsat 5. This is Landsat 7. This is an excellent mission coverage archive. Landsat products, all data older than 2 years, they return to public domain and all are distributed by the IKONOS data center of USGS. This is available at this location. And the Landsat reference system catalogs the world into this number of skiing, 57,784 skiing, each 105 miles, that is roughly 183 kilometers wide. This is a squad by 106 miles, 170 kilometers. This is Landsat imagery. This is a composite of SWIR or shortwave infrared and NIR and red. So it shows man-made features as well as the densely forest area and agriculture. This is you can see that light yellow green color. This represent northern hardwood forest. The dark green patches here, these are the dark green patches, they represent various coniferous species. Then we are coming to IKONOS data. IKONOS high resolution satellite developed by Space Imaging, launched in 1999, still used. Has sun synchronous orbit with crosses equator at 10:30 again, same time. Ground track repeats 11 days, highly maneuverable, can point at a new target and stabilize itself in seconds, enabling it to follow these meandering features. The entire spacecraft moves, not just the sensors. IKONOS data, if you talk about the data of IKONOS, this can collect data at an angle of 45 degrees from the along track and across track axis. This allows for side-by-side and 4.5 scope imaging. It's very good. At its nadir, its swath is 11 km width, so you get a size of 11 by 11 km image. But user-specified strips can also be ordered. It employs a linear array. IKONOS collects panchromatic band also from 0.45 to 0.9 at 1 meter resolution. This is very good resolution. And it collects 4 multispectral bands at 4 meter resolution. So MSS at 4 mm and panchromatic at 1 meter resolution. The band has, you have blue band here, blue, green, red and IR. So radiometric resolution is 11 bit, again 2 to the power 11, very good. It's around 20.